Hi everyone and welcome to this session. My name is Defa Ansokal and today we are going to learn how to conduct a simple linear regression in R software. To begin with, you are going to first load the packages that we require for data visualization, that is ggplot2, dplayer and tidyverse. And after that, you have to note that I'm using a dataset called diet_r_1. This is a dataset with different variables such as age, height, pre-weight, and weight in 6 weeks, and other variables. But I'm only interested in the 4 variables, that is age, height, pre-weight, and weight in 6 weeks. That's why you can see that I'm renaming the columns, that is column 3, 4, 5, 7 to the names that I desire, that is age, height, pre-weight, and weight in 6 weeks. After doing that, you will see that I now have my new dataset called data analysis with the following variables, with only 4 variables, that is age, height, pre-weight, and weight in 6 weeks. So from here, the next thing that we're going to do is to perform a correlation test. This is a test that is used to check if there exists relationship between the variables that you're interested in. And if you to do that, you're going to use a core function in R, and the outcome is, we have an outcome of 0.9584493. This is a high correlation, which means that there exists some relationship between these two variables. The next thing that I'm going to do is to visualize this data to see how these two variables behave when plotted. And we're going to use ggplot function. Just a minute. If you check on your plot area, you can see that there is some relationship between pre-weight and weight in 6 weeks. You can see the dotted lines, they are concentrated along the blue line, which means that there exists some relationship. And the next thing we're going to do is to build our model. And to build our model, we are going to use the LM function. This is a function that is used to conduct linear regression in R. So, on doing that, and we call our model, and we'll find that we have an intercept of 8.1824. And so if we were to write our model, we will say that y hat equals to 8.1824 plus 0.9368 x plus the error term, where x is the weight in 6 weeks. Another thing now we're going to do is to visualize these two variables together with the model that we built. And there we go. Now if you look at that output on the plot area, if you look at this output, you can see that this line is more straight and the data points are concentrated so much along the blue line. So we have ascertained that there exists some relationship between these two variables. So from here, the next thing we are going to do is to do a model assessment. Now, before using this formula to predict weight in future, you should make sure that your model, the model we obtained, is statistically significant. That is, when I say statistically significant, it means that there is a statistically significant relationship between the predictor and the outcome variable. And I also mean that the model that we built fits very well the data that we have at hand. And to check for the quality of a linear regression model, we will start by displaying the statistical summary of the model. And this summary, we'll do the summary of the model using the summary function. And if you do that, this summary outputs 6 components of the outcome. That is, we have the call function. We have the call function. A minute, if I can just elaborate on this. Yes, this is the call function. This function calls is used to compute the regression model. And another thing that we have the residuals. You can see the residuals. You have the minimum, we have the first quartile, median, third quartile, and the maximum. These are the residuals. And these ones, they just provide a quick view of the distribution of the residuals, which by definition have a mean of 0. And another component of this summary, we have the coefficients. You can see the coefficient there. We have the estimated standard error, t-value, and p-value. And these ones, what they do is to show the regression, beta coefficient, and their statistical significance of predictor variables that are significantly associated with the outcome variables. And these outcome variables are marked with stars. You can see the outcome variables are marked with stars. You can see these stars. Then lastly, we have the residual standard errors. We have the multiple R-squared errors and the F statistics. That is the last component. And all these are metrics that are used to check how well the model fits our data. So with this model, we have assessed our model. So we are on the next step that we want to make a conclusion based on the variables that we were interested in. So based on the variables we are interested in, we are going to talk about the t statistics and the p-value. So something we have to note that for a given predictor variable, the t statistics and its associated p-value, they're used to test whether or not there is statistical significance or relationship between the predictor and the outcome variables. This knowledge is based on the hypothesis that we test on our mind, where we have one hypothesis to test, that is we have the H0 and its alternative, where our H0 is coefficients are equal to 0. That is, there is no relationship between x and y, and its alternative is coefficients are not equal to 0. That is, there exists some relationship between x and y. And if we check our outcome on the R console, we can see that we have a high t value, and a high t value translates to a low p value of, you can see there it is less than 2 raised to e. Yeah, that value there, it is a low p value, and this means that our predictor variable, which is weight in 6 weeks, is a significant variable. So if we were to perform a stepwise regression, we will maintain this predictor variable in our model, and we will maintain it in our model. And that marks the end of this presentation. Thank you for watching. Thank you for listening. Don't forget to subscribe for many more videos on the concept of statistical analysis using R software. Bye for now.